Hi everyone, we did the certain results on the Laplace transforms, and once again we can recall the certain results because it is the little bit gap up between the classes. What does the Laplace transform L of f of t definition says? The L of f of t says that integration from 0 to infinity e raised to minus st into f of t dt, and it can be also denoted as a f of s. The L of f of t, the definition says that integration from 0 to infinity e raised to minus st into f of t with respect to t dt is equal to f of s can be written. Now, from this definition, we did already the certain result. What does the L of 1? The L of 1 is 1 by s. By practice, you have to remember this one. What is L of 1? L of 1 is a 1 by s. And L of e raised to kt, it is 1 by s minus k. And L of e raised to minus kt, it is 1 by s plus k, where k is the constant in both the cases. And a certain trigonometric result, L of sin mt is m divided by s square plus m square, whereas L of cos mt is s divided by s square plus m square, and L of sin hyperbolic mt is m by s square minus m square, and L of cos hyperbolic mt is s by s square minus m square. You have to be observe the sin mt, cos mt, sin hmt and cos hmt results. There is a little bit difference in the sin mt and sin hyperbolic mt. M appears in the numerator, and in the cos hyperbolic mt and sin cos mt, s appears in the numerator. Okay, observe once again, and to be remember these things. The first shifting properties also we did. The first shifting property says that L of e raised to at into f of t is f of s minus a. In next, we can go for the Laplace transform of t raised to n, where n is a positive integer. To go for the one more derivation of the Laplace transform, to find out the Laplace transform of t raised to n, where n is a positive integer, or we can say the result L of t raised to n is n factorial divided by s raised to n plus 1. So, for the proof, we need to recall the definition of the L of f of t. By definition, L of f of t is a integration from 0 to infinity e raised to minus st into f of t. Instead of f of t, to put the t raised to n, we get L of t raised to n result. The L of t raised to n is a integration from 0 to infinity, keep the e raised to minus st. Instead of f of t, there is a t raised to n, therefore it is t raised to n dt. What happens? L of f of t is a integration from 0 to infinity e raised to minus st into f of t, and our L of t raised to n becomes a integration from 0 to infinity e raised to minus st into t raised to n. In the right hand side, there are the two functions. One is the e raised to minus st and another one is the t raised to n. Both are the variables in terms of a t. Where there are the product of two functions, we can consider the first function as a t raised to n and second function as a e raised to minus st. Now our work is to evaluate the RHS part by means of integration by parts. What does the integration by parts says that keep the first function as it is, integrate the second function. Okay, I will go through this one. Keep the t raised to n as it is, first function. Integration of e raised to minus st is e raised to minus st divided by minus s minus, again integration from 0 to infinity. Rewrite the integrated function e raised to minus st by minus s and differentiate the first function t raised to n differentiation n into t raised to n minus 1 dt. It is by the integration by parts. Okay, I will recall the once again. What is the integration by parts? Keep the first function as it is, integrate the second function minus integration of integrated function and differentiate the first function. Okay, now the first bracket, whatever it is, t raised to n into e raised to minus st divided by minus s with limits 0 and infinity. Put the t as infinity at once minus t as 0, upper limit minus lower limit. Whenever t can be taken infinity, that is e raised to minus infinity will come. t raised to t is can be taken as a infinity, e raised to minus infinity. The e raised to minus infinity is written as a 1 by e raised to infinity. 1 by e raised to infinity means 1 by infinity, and it is 0. Anyhow, what does the result whenever t equal to infinity in the first bracket? It is the 0. Put t equal to 0 in the t raised to n into e raised to minus st by minus s, that also becomes a 0. Therefore, the bracket evaluation t raised to n into e raised to minus st by minus s with limits 0 into infinity is a 0. Now the second part, minus whatever it is, 0 to infinity e raised to minus st by minus s into n into t raised to n minus 1 dt, where it is minus and n and s, that is minus n by s is common and they are independent from t. Therefore, it is there is the outside the minus, and minus n by s comes outside the integral sign, it is plus n by s. The remaining thing is integration from 0 to infinity e raised to minus st into t raised to n minus 1. So the L of t raised to n result becomes a n by s L of t raised to n minus 1. This part, if it is 0 to infinity e raised to minus st into t raised to n, we written that L of t raised to n. Instead of there is a t raised to n minus 1, therefore it is written as a L of t raised to n minus 1. So the one explanation says that L of t raised to n is n by s into L of t raised to n minus 1. Observe, L of t raised to n is n by s. L of t raised to n is n by s. Now the remaining Laplace is t raised to n minus 1 left. That is L of t raised to n is a n by s into L of t raised to n minus 1. You may call this expression as a 1. Now what does the L of t raised to n minus 1? With the help of L of t raised to n, we may write the L of t raised to n minus 1. If it is t raised to n, it is n by s. If it is t raised to n minus 1, n minus 1 by s. If it is t raised to n, in the bracket it is a, in the Laplace it is t raised to n minus 1 left. Here it is n minus 2 left. Anyhow, to recall this one, L of t raised to n is n by s into L of t raised to n minus 1. L of t raised to n minus 1 is a n minus 1 by s into L of t raised to n minus 2. Similarly, the L of t raised to n minus 2, n minus 2 divided by s into L of t raised to n minus 3. Continuing this process and substitute all these results in the L of t raised to n, what happens? L of t raised to n becomes a n by s into n minus 1 by s into n minus 2 by s into so on to be into 1 by s into L of t raised to 0. So it is n minus 1, n minus 2, n minus 3 and so on to be into 3 into 2 into 1 is in the numerator, s into s into s at n times in the denominator. The remaining thing is L of 1. The L of 1 is t raised to 0 is L of 1. L of 1 is a 1 by s. So in the numerator it is n into n minus 1 into n minus 3 into n so on to be 3 into 2 into 1 is written as a n factorial divided by s raised to n into s is a s raised to n plus 1. Therefore, L of t raised to n is factorial n divided by s raised to n plus 1. With the help of this one, instead of n, we can put the number, and to practice this one, as L of t raised to n is a n factorial divided by s raised to n plus 1. If it is n as a 2, it is 2 factorial divided by s raised to 2 plus 1. That is 2 factorial is a 2, 2 divided by s raised to 3. And L of t raised to 3 is a 3 factorial divided by s raised to 3 plus 1. That is 3 factorial is a 6, 6 divided by s raised to 4. Similarly, L of t raised to 4, 4 factorial divided by s raised to 5. That is 24 divided by s raised to 5. Similarly, the L of t raised to 5, 5 factorial by s raised to 5 plus 1 is s raised to 6. That is 5 factorial is a 120 divided by s raised to 6. Students, you can go through the derivation of L of t raised to n and practice and repeat it up to the perfect, and it is most important for the examination also. And to remember this one, for this we can work out some examples like that, whatever I written L of t square, L of t cube, L of t raised to 4, L of t raised to 5. Instead of the power n, we can put the numbers, we can get the results. Some more examples.